All right, we're going to look at Chapter 11 today on radicals, and this one is on section 11.5, radical equations. So, with solving radical equations, if x is greater than or equal to 0 and a is greater than or equal to 0, then we have the square root of x is equal to a if and only if x is equal to a squared. Okay, and so that's kind of a key there. And then in general, if x is greater than or equal to 0 and a is a real number, then we can have the nth root of x is equal to a if and only if x is equal to a to the n. And so this is going to help us get to solving radicals. So what we're going to do is we're going to have something like this, and what we're going to do is we're going to square both sides. And when you square the square root, you just get the x. When you square the a, you get the a squared. Here, we're going to take this to the nth power, and so when we do that, we'll get x, and when we take a to the nth power, we get a to the n. And so that's how we're going to get rid of radicals and actually solve these equations. So the overall steps for solving radical equations is to first isolate the radical on one side of the equation. So as we see here, the radical is on one side, everything else is on the other. Now, if there are two radicals, say we had, maybe the square root of x minus the square root of 2x or something like that, then what we want to do is isolate one on the one side, and then basically we'll have to do all the steps over once we get so far. So we're going to have, say if that was equal to 4, then we'd have to take this to that side. We'd square both sides, and when we get done, there's going to be a radical now on this side, and then we're basically going to have to go back into isolating the radical on one side of the equation again, and then solve from here below. And so then what we do is once we have the radical on one side, we raise both sides of the equations to whatever the root is. So if it's a square root, we raise it to the power 2. If it's the nth root, we raise it to power n. Then we solve the equation as usual. So what's going to happen is you're probably going to get a trinomial. We'll have to factor it, and then we're going to set each factor equal to 0 and solve for x, y, z, whatever it is. And then we're going to have to check our solutions. That's going to be the last step, verify that the solution works. Some are going to work, some are not going to work. And so we're going to have to really check through all of them to know which one does or does not work. All right, so let's start. And again, it says solve, but also to be sure to verify all solutions. And our first step was to get the radical by itself. So that means we have to add x to both sides. All right, so when we do that, we get the square root of 6x minus 5 equals x. Now we square both sides because we have a square root, so we're going to square that. We're going to square that. Well, when we square a square root, we get 6x minus 5, and that's equal to x squared. Now we have only values with x's in the numbers. So that means it looks like we can get this to be a trinomial by subtracting 6x and adding 5. Subtract 6x and add 5. So on the left, we get 0, because that's how we want to solve these equations. Then we get x squared minus 6x plus 5. And now we get to have the fun part, and all these, I think, all have factoring involved. And so x squared, we know, is going to be x and x. Here we have a plus, here we have a minus. We have a minus and a minus. And there's only two factors of 5, 5 and 1. So now let's check, FOIL it back out. We get x squared, then we have minus 5x, minus x, so that's minus 6x, and then plus 5. Each of these factors equal to 0, so x minus 5 equals 0, and x minus 1 equals 0. So here x is equal to 5, taking the 5 over, and here x equals 1, taking the 1 over. Now we have to check and see which one or both or neither one works. So if we plug in a 5 here, so that'll give us 6 times 5 minus 5, and we'll extend that, and then minus, and now we had a 5, and that's equal to 0. Well, 6 times 5 is 30, minus 5 is 25, so the square root of 25 minus 5 equals 0. Well, the square root of 25 is 5, and so that one checks. Now what about the other one? So we take the square root of, now here we have 6 times 1 minus 5, and then minus 1 equals 0. Well, that's 6 minus 5, well that's 1, so the square root of 1 minus 1 equals 0. Well, the square root of 1 is 1, so 1 minus 1 equals 0. That checks as well. So both of these are actually solutions to this problem. All right. And so that's how you solve one of these equations, and also how to verify it. All right, what about this one? Do the same thing. First, we're going to get rid of this 1 because we want the radical by itself, so we'll add 1 to both sides. And so we'll have the square root of 3 minus 3x equals 2x plus 1. Now we'll square both sides to get rid of that radical. Now this is going to be a binomial squared, so we have to, FOIL it back out or remember the perfect square formula. And so when we do this one, that just gives us 3 minus 3x. Now when we square this, if you need to, you can write it out again, 2x plus 1 and 2x plus 1. And then we'll take 2x times 2x, that's going to give us 4x squared. Then we'll have here first and last, so that's going to be 2x. And here's another 2x, so it's going to be plus 4x. And then 1 times 1 is 1, okay? Now we've got x squareds that are positive on this side, so I'm going to take everything to the right. So I'm going to subtract 3 and add 3x. So add 3x and subtract 3. So 0 equals 4x squared plus 7x. And then here we have 1 minus 3, so it's going to be minus 2. All right, now we get a factor. And seeing that we have a 7 here, and I know if 2 times 4 is 8, I'm going to assume it's going to be 4x and x, and then a 2 and a 1, and now I have to determine what the signs are. I need a positive 7, so I need the larger one to be positive, so 2 times 4 is 8, so it needs to be positive. This one needs to be negative because we get done, we need a negative here. And so let's multiply this back out. 4x squared, then we have 8x minus x, which is 7x minus 2. So we factored that one. And so now what we do is we set each of these equal to 0. So we have 0 equals 4x minus 1 and 0 equals x plus 2. Well, here we're going to add 1 to both sides. So we get 1 equals 4x. Now we divide by 4. So x equals 1/4. And here we just subtract, so that's equal to negative 2. Okay. All right, well, if we plug these back in to verify, we'll have the square root of 3 minus 3 times 1/4, and then minus 1 equals 2 times 1/4. All right, so here we have 3 minus 3/4, and that's a square root. And then we have minus 1 equals, here 2 times that's just going to be 1/2. All right, so getting common denominator, we'll have 12 minus 3, so that's going to be 9/4. So we have 9/4, the square root of that, minus 1 equals 1/2. Well, the square root of 9 is 3. The square root of 4 is 2. Now, 3/2 is 1.5, minus 1 is 1/2, so that checks. Okay, so that one we know is good. So what about the next one? So then we have 3 minus 3 times negative 2, square root of that, minus 1 equals 2 times the minus 2. Well, here 3 times 2 is 6, and then that's positive, plus 3, so that's the square root of 9, minus 1 equals, here that's going to be a minus 4. Well, the square root of 9 is 3, minus 1, minus 4. Well, that's 2 equals a minus 4. That's not true, so that one doesn't work. Okay, so sometimes they work, sometimes they don't. So you really have to verify each one of them to be sure that you have a true solution or not. All right. Here we got one that has the 2 square roots. So what I'm going to do is I'm going to add just this one to the other side. And so when I do that, then I have the square root of 2x plus 4 equals 1 plus the square root of x plus 3. Then I'm going to square this side, and I'm going to square this side. So when I square this side, we just get 2x plus 4. Now when I square this, we have to think about that. We have to multiply. So it's 1 plus the square root of x plus 3 times 1 plus the square root of x plus 3. So 1 times 1 is going to give us 1. And then here we have square root of x plus 3 plus the square root of x plus 3. So that's plus 2 square root of x plus 3. And then we have that times that. So that's basically that squared. And so then plus x plus 3. Okay. So rewriting that, that gives us x and then plus 2 square root of x plus 3, and then 3 plus 1 is 4. So on the right, that gives us x plus 2 square root of x plus 3, and then plus 4. All right, now we still have a square root, so we're now back to step 1 again, where we get this all by itself. So I'm going to subtract x and subtract 4. Subtract x, subtract 4. So 2x minus x is x, 4 minus 4 is 0. And then on the right, we get 2 square root of x plus 3. Okay. Now here we could go ahead and divide by 2, but I'm just going to square both sides. So I'll square that and I'll square that. So x squared is here equals, well, 2 squared is 4, and this squared is just x plus 3. Okay. Oh, where did my squared term go here? There we go. Now I have to distribute, so I have x squared equals 4x plus 12. So now minus 4x minus 12, minus 4x minus 12. And so I get x squared minus 4x minus 12 equals 0. Now I need to factor that, and so I'll go over here, and that's going to be x, and 2 factors of 12 that subtract to 6, or subtract to 4. So 6 and 2 subtract to 4, so a 6 and a 2. The larger has to be negative. So now let's test. That's x squared, and we have minus 6x plus 2x, so it's going to be minus 4x minus 12. So now we set each of those equal to 0, so x minus 6 equals 0, and x plus 2 equals 0. So x is equal to 6, and x equals a negative 2. Now we have to verify both of those. So the first one is going to be the square root of 2 times 6, which is going to be 12 plus 4 minus the square root. Now 6 plus 3 is 9, and that equals 1. So 12 plus 4 is 16. The square root of 16 is 4. Now the square root of 9 is 3. That's equal to 1. Yes, so that works. What about minus 2? So here we'll have the square root of negative 2 times that's going to be a negative 4 plus 4 minus the square root of negative 2 plus 3, and that equals 1. And so we have 0 minus, now this is going to be a square root of 1, and so negative 1 equals 1. No, so that one doesn't work. Okay. So, you know, at this point, you might have thought, oh, that's square root of 1 equals 1. Yeah, that works. But you have to remember we have that negative there. So it's negative 1 equals 1, which is not true. All right, here's another one. The same kind of thing. We have 2 square roots. So we're going to have 2 steps. So I'm going to go ahead and take and add that to the other side. So when I go ahead and simplify that, that gives me the square root of 6 minus 2x equals 3 plus the square root of 2x plus 3. Okay, now we're back to squaring both sides again. And so I square that, that's 6 minus 2x. Now this one is going to be, instead of writing it all out, it's going to be square the first one, so that's going to be 9. And then plus 2 times 3 times this, so it's going to be 6 square root of 2x plus 3. And then square that, that's 2x plus 3. And so now I've got a 9 and a 3, so that's going to give me a 12. And then I have plus 6 square root of 2x plus 3 plus 2x is equal to 6 minus 2x. All right, so now what do we do? Well, now we're going to subtract our 2x, and we're going to subtract our 2x. We're going to subtract our 12. We're going to subtract our 12. And we'll have a little dip in our sign there, whatever. And so 6 minus 12 is going to give me a negative 6. And the minus 2 is going to be minus 4x. And that is equal to 6 square root of 2x plus 3. Okay. Now what do? Well, we square both sides. All right, so when we square this, we're going to basically do the same thing we did here. We're going to take -6 times -6, and we get 36. Then a 2 times a -6 times a -4, so 6 times 4 is 24, times 2 is going to be 48, and it's going to be a positive 48x. And then square that, that's going to be plus 16x squared. That equals, well, 6 times 6 is 36. This just is 2x plus 3 after we've squared it. Now we have to simplify on this side, so it looks like it's going to be a 72x plus, and that's going to be 108. And then we still have, now let's rewrite it in decreasing powers. And so that's what we have. All right. So now what do we do? Well, I'm going to subtract 72x, then I'm going to subtract 108. So I'm subtract 72x, subtract 108. Now let's see if we can get this here without it telling me I'm too out of room. And 48 minus 72 is going to be a minus 24x. And 36 minus 108 is going to be a minus 72, and that's equal to 0. All right, so let's go up here and rewrite that because I think there's some factors here. We have x squared minus 24x minus 72 equals 0. Now I think we have 8 will go in here, 8 will go in here, and 8 will go in here. So I'm going to multiply everything by 1 over 8 just to get rid of that common term. So 8 will go in here, and that's 2x squared. That's going to be minus 3x. That's going to be minus 9 equals 0. And now that's going to be a lot easier to factor. All right, so I now have 2x, x, and then factors of 9. When you have a perfect square like that, I'm going to try 3 and 3 just to see. So I have a 6x and a 3x, and so if I subtract those, that'll give me 3x. So I'll have to have a negative here and a positive here. So that's going to be 2x squared. Then minus 6x plus 3x is going to be minus 3x and then minus 9. And so then I get 2x plus 3 equals 0 and x minus 3 equals 0. So x here is negative 3 over 2. Here x is equal to 3. Okay. Now we get to plug both of those back into our original equation and see what we get for an answer. So let's do the easy one first, the 3. So square root of 6 minus square root of 2 times 3 plus 3 equals 3. This looks like it's going to do the same thing as the last one here. 6 minus 6 is 0 minus. Here we have 6 plus 3 is 9, so square root of 9 is 3. And that equals 3, and that one doesn't work. Okay, so hopefully the other one does. So now we'll do it here since it's probably going to take more room. 6 minus 2 times negative 3 over 2. Try to write it legible, minus 2. And this is a square root, and it's going to be minus 3 over 2 plus 3, and that's equal to 3. Well, here when we do this, the 2 cancels a 2, and a minus is going to be plus. So 6 plus 3 is going to be 9. So square root of 9 is 3. Here 2 cancels 2, and we get minus 3 plus 3 is 0. So minus 0 equals 3. That one works. And so this one is actually the answer in this case. All right. So again, you have to do both of them to get the correct solution because, you know, we came up with 2, one of them doesn't work, but the other one does work. All right, what about this one? Again, a lot of these are going to give you double square roots just because it's going to be the longer, a lot more steps to work. And so, you know, again, multiplying, when we get done, we need one of these here by itself. So we have to add x, square root of x to both sides. So then we get the square root of x plus 2 equals 2 plus the square root of x. Now we square both sides, multiplied that by that, and we just get x plus 2. Here we're going to get 4 plus 4 square root of x plus x. Again, just foiling it out in my head. I'll have square that one to get 4. Then I'll take 2 times that, and I'll get 4 square root of x, and then square that one, I get x. Now I'm going to subtract 4 and subtract x, subtract x, subtract 4. So here x minus x is 0, 2 minus 4 is negative 2, and over here we get just the 4 square root of x. Now I'm going to square both sides. And so I get 4 equals, now 4 times 4 is 16, x times x is x. Okay, well, now this is simple. All I have to do is divide by 16, and I get x equals 1 over 4. So now we have to check. So we plug in 1 over 4 here. So the square root of 1 over 4 plus 2 rather, and then minus the square root of 1 over 4, and that equals 2. Well, here if we get common denominator, that's 4 over 4. So here we have 8 plus 1, so that's going to be a square root of 9 over 4 minus, now we have the square root of 1 over 4, and that's equal to 2. Well, the square root of 9 is 3, square root of 4 is 2. Here we have square root of 1 is 1, square root of 4 is 2. 1½ minus 1/2, does that equal 2? No. So guess what? This one has no solution. Okay, so sometimes you get down and you don't even get one of them to work. So that's how it works. All right, so that's where I'm going to stop here, and then I'll do another video doing another 5 or so problems.